Well, after we got all that other preliminary work done, all of that is getting ready to do what this is all for, where we have to find all the real zeros of a polynomial. We have one more little tidbit we have to address, and that's Descartes' rule of signs. Descartes' rule of signs is a super important little rule and something that's kind of valuable. So let's take a look at what it says. Descartes' rule of signs says that when you take your polynomial, f of x, and look at the number of sign changes between the terms. So here, this first term is positive, second term is negative, that's a sign change. Next term is negative, so these two are both negative, that's not a change. But now we go negative to positive, that's another sign change. Positive to positive is not. We see two sign changes. So that means Descartes figured out that there will be either 2 or 0 positive real zeros. Now notice I didn't say rational, I said real. Positive real zeros. That includes irrationals like the square root of 2 or the square root of 5. So we know that Descartes says because there are two sign changes, there have to be 2 or 0. It always goes down by 2s. So if that would have been a 3, it would have been 3 or 1. And then you'd stop. Then you do f of negative x. And of course, all that's going to do is on all of the odd degree terms, it's going to change their sign, but on all the even degree terms, the sign will not change. So this stays 2x to the fourth, but the negative 7x cubed becomes positive because a negative x cubed times negative 7 is positive. The negative 8x squared stays negative 8x squared, but the 14x becomes negative 14x. And of course, the constant's not going to change. So we go through here and we see that there are two sign changes. And so that means there are 2 or 0 negative real zeros. So just to show you what that kind of looks like. So you have a fourth degree polynomial. It could look like this. And this would show you 1, 2 negative real zeros and 2 positive real zeros. But it could have looked like this, where it came down like this, and we had no negative real zeros, but we had 2 positive real zeros. The other 2 zeros would be imaginary. And it is possible that the entire thing would never cross the x-axis, and you'd have no positive real zeros and no negative real zeros. All right, well, let's now do the problem. What are all my possible rational zeros? Here, remember, the whole bottom line of why we're doing all this is we're basically trying to solve the equation 2x to the fourth minus 7x cubed minus 8x squared plus 14x plus 8 equals 0. We're basically trying to figure out what are the zeros, set it equal to 0 and figure out, what it is. Well, obviously we're not going to be able to factor it. There's no formula like the quadratic formula for a fourth degree polynomial, so we have to guess. Well, you don't just want to random guess. That's what all this work we've been doing is for. We know what possible rational zeros we can have are going to be p over q. P are all the factors of the constant, 8. So that's 1, 2, 4, and 8. And then Q, all the factors of the leading coefficient, 2, 1, and 2. And we list out our P over Q, or all of our possible rational zeros. Now, this is where that little trick I showed you comes in. We're going to do synthetic substitution to try and guess which of these will work. Now, understand this. Here's what would happen if you didn't use my method. You would have to write out, whoops, what the heck was that? You'd have to write out and do one of these synthetic divisions and put in 2, negative 7, negative 8, 14, and 8. And you're going to try a 1. You're going to do all that work. It doesn't work. And then you got to draw another one. And you got to write down 2, negative 7, negative 8, 14, and 8. You try another number and it doesn't work. Then you got to write it down again to, I think you get the picture. I'm not wanting to do all that stuff. This is pretty slick. Another teacher showed me this a long time ago, and I thought it was really cool. Again, the shortcut. So what we do is we're going to write, I'm going to make my line just a little thicker here. We're going to make our kind of like our little T here or cross or whatever, and we're going to put in our coefficients: 2, -7, -8, 14, and 8. Now, we know that 0, 8 is a point on this graph. We know that if you went to graph this thing, there'd be a point at 0, 8. We know the end behavior is 4th degree, and it opens up, and we know it goes there. That's what we know so far. Now, we're going to try, the easiest one to try always is first is 1. So let's run through what happens. We try to see if 1 is a 0. So we bring down the 2, and 2 times 1 is 2, and we add that to -7 and get -5. -5 times 1 is -5, plus -8 is -13. -13 times 1 is -13, plus the 14 is 1, and 1 times 1 is 1, plus the 8 is 9. Now, what did we just find out? We found out that 1 is not a 0, but we also know something else. We know that f of 1 is 9. And so if you plug a 1 in, okay, if this was, I'm going to redo this here and make it look a little bit better. Change that to black, and if we make okay, and so we know, let's say that's 2, 4, 6, 8. So we know that was the y-intercept was 8. And now we know f of 1 is 9, so it actually went up higher, didn't it? And so now we try our next number. So we go through our list and we try a 2. So we bring down the 2 again, and 2 times 2 is 4, plus -7 is -3. -3 times 2 is -6, plus -8 is -14. -14 times 2 is -28, plus 14 is -14, and -14 times 2 is -28, plus 8 is -20. That is very significant because we know that f of 2 is -20. That's going to be way down here somewhere. That means that this thing has, it had to come up, and it's going to come down and go right down through there like that. And so if it's going to cross from a positive number to a negative number, then it has to cross through 0. And the intermediate value theorem, if you recall that, says that this function, since it's continuous, all polynomial functions are continuous, it has to contain all values between f of 1 and f of 2. And since f of 1 is 9 and f of 2 is -20, then there has to be a value c in between 1 and 2 that's going to contain every number between 9 and -20, and 0 is in that number, so it's got to be a c such that f of c equals 0. That's the intermediate value theorem. Okay, well, that was just a little review. You just need to understand that, hey, common sense says there's got to be a 0 somewhere between 1 and 2. So the next thing you might try is a number between 1 and 2. What would that be? Well, that'd be like 1.5 or 3/2. Well, the problem with that is there aren't any rational zeros between 1 and 2. The only ones we have are 1, 2, 4, 8.5, and that's not between 1 and 2. So there must be a 0 between 1 and 2, but it's going to be irrational. And so it could be an irrational like radical 2, because that's 1.4. All right? But we don't know what it is. So now we got to try another one. Well, we've already found that there's going to be either none or two positive real zeros, right? And this is a positive real zero, and it's irrational. So I guess it's, we know it has to probably come back up again. But at this point, it looks like, and you could go ahead and you could try 4. And there's really no, there's no right answer as to what you should try next. You could try 4, and then you could try 8. But I chose to go smaller numbers, and I chose to try -1 because you know that there's 2 or 0 negative real zeros. So I tried -1. I bring down the 2. 2 times -1 is -2, and -7 add up to -9. -9 times -1 is 9, plus -8 is 1. 1 times -1 is -1, plus 14 is 13. And 13 times -1 is -13, plus 8 is -5. Okay? So we know that 0 was 8, and now we know -1 is -5. So now that means what? There must be a 0 somewhere between 0 and -1. All right? So we could try -1/2, right? And we do. So we try -1/2. Bring down the 2. -1/2 times 2 is -1, plus -7 is -8. -8 times -1/2 is +4, plus -8 is -4. -4 times -1/2 is +2, plus 14 is 16. 16 times -1/2 is -8, plus 8 is 0. Yippee-yi-yay! We just found our 0. So we know now that if f of -1/2 is 0, that x plus 1/2 has to be a factor. So we can now factor this thing out a little bit. We have f of x equals x plus 1/2. And then it's 2x cubed minus 8x squared minus 4x plus 16, which I write right here. Now, anytime you get these fractions in here, you're going to be able to factor a number out, and we're going to be able to get rid of this fraction. You're going to factor a 2 out of all these terms. So it's 2 times x cubed minus 4x squared minus 2x plus 8. Then I'm going to take the 2 and multiply it by x plus 1/2 and get 2x plus 1. So that makes it look a little nicer. We don't have those fractions in there. And then we look at this, and it's got 4 terms, but sometimes you can factor 4 terms in a cubic by grouping. So we take and look at, I'm going to change that back to red. We look at x cubed minus 4x squared. And we're going to group those together, and we're going to group the -2x plus 8. We can factor an x squared out of the first 2 terms. And so we take out x squared, and we're left with what? X minus 4. And then we can factor a -2 out of the last 2 terms, and you're left with x minus 4 again. And as long as you get the same thing in the parentheses, you're going to be able to factor it now, because that's like the same number both places. So you can factor out x minus 4, treating it like a single number. So it then becomes x minus 4 times the x squared minus 2 here. And then the x squared minus 2, you could factor that into x plus radical 2 and x minus radical 2 if you wanted to get to see what the zeros are. But we know that that's going to be radical 2 and negative radical 2 are my zeros. So our zeros are going to be -1/2 from this one, +4 from this one, and plus and minus radical 2 from this one. Or again, like I said, you could factor that into x plus radical 2 and x minus radical 2. So we found all of our zeros. All right.